Now I want to show you the enterprise method using layer 3 switch with SVIs. Same address scheme, which is 10.10.1.0, 10.10.2.0, and then 10.10.3.0. So it's just going to be the same VLANs, which is 10, 20, 30. But this time, inter-VLAN routing happens inside the switch hardware, right? Not external router. So there's no external router that is needed, for the LAN inside. So in this scenario, the WAN routing will still be our router, Johannesburg router, because the serial WAN links are on that router. But the logical inter-routing between finance, HR, and IT is handled by the layer 3 switch, right? So this is the separation of concerns that is used in enterprise design. Layer 3 switch for LAN routing, and then router for WAN routing. Now for this demonstration, I'm going to be using the 3560 router, multi-layer switch. So I'm just going to put it somewhere here. And I'm going to just remove the connection. Okay, I need to deselect. So I'm going to remove this connection, and then I'm going to connect it to the switch. Gigabit to this switch. We can just put it on gigabit 1. All right, the router connection, we can actually do it later on. So basically, I'll just connect the 2960 access switch, which is Johannesburg 01, to it via a trunk. Same PCs, same IPs, same VLANs, only just the inter-VLAN routing device changes. Right, now we're gonna click on our multi-layer switch and then configure that. Just trying to get the window here, and we're gonna go to CLI. All right, and then we're gonna go CLI, and then enter enable, and then configure terminal. Host name is it's SW3 JHB 01. Now here's a critical step. We need to enable a layer 3 routing engine. So without this, the SVIs have IPs, but they will never route anything between the VLANs. So we'll say here IP routing, and then step 2 is to create a VLAN. So we've got VLAN 10, and then the name is finance, and then we've got VLAN 20, and then name is HR, and then we've got VLAN 30, and then the name is IT. So name is IT. All right, and then step 3, we need to create the SVIs. So that's 1 per VLAN, matching our address scheme. So that's going to be interface VLAN VLAN 10, okay, let me just type this Okay, and then let's give it an IP address. IP address is 10.10.1.1 and then 255.255.255.0, and then no shutdown, and then exit. All right, and then we do interface. Okay, I'm just gonna do the up arrow. So there's gonna be VLAN 20. And then IP address 10.10.2.1 and then 255.255.255.0. And then no shutdown. And then exit. All right, and then let's do VLAN 30. So I'm gonna use VLAN 30, and then IP address is 10.10.3.1 and then 255.255.255.0, and then no shutdown, and then exit. All right, now on step 4, we need to configure the trunk uplink to access the switch Johannesburg 01. All right, so we can just say interface gigabit Ethernet 0/1. Now the 3560 switch actually requires the .1Q encapsulation specified explicitly, so we'll just say switch port trunk encapsulation .1Q and switch port mode trunk then switch port trunk allowed VLAN 10, 20 and 30, and then exit, and then end. All right, so just 4 critical points about this configuration. Point 1, IP routing. This is the single most important command in the entire layer 3 switch configuration, because it activates the routing engine. So without it, the switch is a layer 2 only, and then the SVIs will have IP addresses, but they will never route a single packet between VLANs. So I've seen students who configure everything perfectly and then spend an hour troubleshooting before realizing that this one line was actually missing. So point 2, the interface VLAN 10, which is a capital V. You see there we use the capital V, lowercase LAN, no space, so VLAN number immediately after. So this creates the SVI. So the IP address 10.10.1.1 is identical to what we used in the router on the stick in sub interface. So the PC default gateways do not change at all. And then point 3, no shutdown on each SVI. SVIs are shut down by default if the VLAN does not exist, or maybe it has no active access ports. So always bring them up explicitly. And then point 4, switch port trunk encapsulation .1Q on the 3560. The 2960 access port does not need this. It only supports .1Q, so it auto assumes .1Q. So 3560 actually supports both .1Q and the older ICL standard. So you must tell it which one to use before setting switch port mode trunk. So you miss this and then you get an error, basically. And then so basically 3560 trunk config difference is that 2960 only needs switch port mode trunk, and then 3560 needs switch port trunk encapsulation .1Q first, then switch port mode trunk. So these distinctions, I mean, if you're taking your CCNA exams or anything like that, it's going to appear. So you must know that. So the error message on 3560, if you forget this, is command rejected. All right, now let's show everything just to make sure. So we can just show IP IP interface brief. All right, and then we can also show IP route. All right, so now let's go ahead and we need to actually connect we can connect this guy to this one. Which one did you configure? Was it 0/1? So let's just wait for it, and then we will actually ping. Oh, sorry, not this one. Oh my word. I was like, cancel. So let's remove this connection here. Wrong connection. So it's supposed to be this one. Gigabit, and then like this. All right. So it was just an error. Let's just wait for it. All right, now it is fully landed. So I'm gonna go to finance PC, and then I'm gonna ping the HR PC, which is 10.10.2.1. Command prompt. So let's ping 10.10.2.10. So remember, the first one is timeout. It's always the case. So but if we run it again, so there we go, same results, 4 out of 4. Finance reaches HR, but this time There is no sub-interface configuration on the external router, so no encapsulation command, no .1Q tags leaving the switch. So the routing happens in the hardware inside the 3560. So in a dedicated, ASIC at a wire speed. So in a 500 device enterprise network, this performance difference is enormous, right? For example, if I can give you an example, let's take MTN for example. Let's say maybe MTN South Africa's campus network in Fairland. They might be using Cisco Catalyst 9000 series multi-layer switches, right? So the enterprise successor to the 3560, that one. So as a distribution switches. So each floor's access switches connect to the distribution layer via a 10G trunk links or 10 gigabit trunk links. So inter-VLAN routing between MTN's finance, network operations, engineering, and IT departments all happened at the distribution layer using SVI, exactly like what we just configured, but at a massive scale. All right, so so what we've actually built a VSLM design IP addressing scheme, a 3-site WAN with serial links, inter-VLAN routing, a Johannesburg HQ using router on the stick, and a complete departmental VLAN structure. So this is the real working enterprise network. So now the next time we meet, we will talk about spanning tree protocol. So we're going to deliberately add redundant links to our switch topology. So and then watch a broadcast storm destroy the network and then fix it with STP. All right. So it is the